Hi everybody. Today's video is going to be about arithmetic sequences. So we talked in general about sequences in 12.1, kind of this pattern of numbers, and a specific type that we're going to study a bit is an arithmetic sequence. And we like arithmetic because it follows a pattern of addition. So essentially we have any pattern where we're adding what we call a common difference. Okay, we take a sub 1 is the first term and keep adding a common difference. And basically what you can notice here is that if I were to number these terms here, and I know it's kind of hard to tell, we got the first term, so if I said n equals 1, and then this is n equals 2, n equals 3, n equals 4, n equals 5, you'll notice that the number of times we're adding the common difference is one less than the number of term, because that first term we don't actually add the common difference. All right, so that gives us this formula. This is our explicit formula for an arithmetic sequence. And we get that it's a sub n equals a sub 1 plus n minus 1 times the common difference. One of the things you'll notice in the book is they just call the first term a. I don't really like that. I like it having that subscript of 1 to tell us it's the first term. But if you ever see the book say a, it's just talking about the first term. Now before we go to the first example, I want to add one more little formula here for us, and it's this idea of calculating a common difference. The common difference is the number we're adding to find the next term. So we can always calculate the common difference by taking a term, and if I wanted to just write a term in general, I'd say a sub n, and I can subtract the previous term, a sub n minus 1. That's a little useful formula for finding the common difference. So let's look at a problem like 1. Find the nth term. That really just means write an explicit formula. A sub n. I want to be able to find any term I want, the nth term. So in order to do that, I need the first term and I need the common difference. Well, if I look at the sequence, negative 2, 3, 8, you can probably come up with the common difference pretty quickly. But let's just pretend we can't. Pretend we don't have any ability to do like addition just by looking at it. Like we have to use this formula. So I could pick any term I wanted. Let's pick 8. And I could subtract the term in front of it, 3, and I would get the common difference is 5. Ta-da! Oh yeah, that was what it was, plus 5 every time. I also already know the first term. It's negative 2. So I can very quickly and easily write my nth term by using the formula. A sub n equals first term plus n minus 1 times the common difference. I like this as a final answer, but a lot of people also like to convert it to kind of what looks like slope-intercept form. Basically simplify it. So we could distribute that 5 and we would get equals negative 2 plus 5n minus 5. And then I can combine the negative 2 and the negative 5, and I get 5n minus 7. So that's another good answer for an arithmetic sequence, explicit formula. Either one is okay. I think you should be able to be comfortable getting either. The recursive form of this, remember a recursive formula requires two things. It requires the first term, same as explicit. And we state the nth term by comparing it to the previous term. Well, what do I do to the previous term every time? I'm adding 5, because that's the common difference. So the recursive formula is this two-part thing. A sub 1 is negative 2, and a sub n equals a sub n minus 1 plus 5. Off to the side here, I just have a little graph to kind of like show us what a graph of this looks like. Where I have the n-axis and the a sub n axis, essentially. And you can see that this sequence is going up 5 units every time. And it's not connected because this isn't a function where n is continuous. All it is n is made up of the integers greater than or equal to 1. So 1, 2, 3, 4, 5, those are the n values, continuing on. And notice it makes a straight line. An arithmetic sequence is akin to a linear function. All right, number 2. Given the 12th term of an arithmetic sequence is 41 and the 50th term is negative 35, find the nth term. Another way those could be written is a sub 12 equals 41 and a sub 50 equals negative 35. Find the nth term. Well, same thing. If I want to find the explicit formula, I need a first term and I need a common difference. Well, I could list this out and just try to figure out how much it would take to get from the 12th term to the 50th term. But we know it's the same amount every time. So we can use the idea of that graph that we just saw, because the common difference is really just the slope. So I'm essentially going to treat this like slope. I'm going to go a sub 50 minus a sub 12 over 50 minus 12, essentially treating it like a slope. And so you get negative 35 minus 41 over 38, and what is that, 76, negative 76 over 38, so my common difference is negative 2. Okay, well, I don't know my first term. I could, I guess, count backwards from there, but I could use essentially my formula, a sub n equals, I don't know the first term, plus n minus 1 times, I do know the common difference is negative 2, and I could plug in one of the terms that I know, let's say the 12 and 41. So the term is 41 equals a sub 1 plus the n value is 12, and I can solve this out. 41 equals a1 plus, that'd be 11 times negative 2 is negative 22. So we add 22, we get our first term is 63. So I can write my final answer as a sub n equals a sub 1, 63, plus n minus 1 times negative 2. Okay, so that's an arithmetic sequence. Let's talk about a sum, or a partial sum of an arithmetic sequence. So first, by not being in school, I don't get to tell my fun story here, so I'm going to tell it on the video. There's a famous story about Carl Gauss, a famous mathematician. When he was elementary school, maybe first or second grade, and he was in his class, and the teacher was just wanted to give them some busy work. She needed some time to grade some papers, and so she gave them a task and said, I want you guys to add up the first 100 numbers, 1 through 100, add them up. And Gauss had an answer very, very quickly, way quicker than she thought it would take, and it turned out to be right. So how did he do it so quickly? Well, kind of noticed a pattern. So if we rewrite this, 1 plus 2 plus 3 plus 4 plus 5, and continue that on, and added from 100, plus 99, 98, you notice that all these pairs, so basically pairing up every number, the 1 and the 100, the 2 and the 99, adds up to 101. And he knew that there would be 50 of those pairs. And so we would essentially have 101 times 50. And when he did that out, you end up with 50/50, which is the correct sum. So that leads us to a formula for the partial sum of an arithmetic sequence. And the book has a couple of them. and I tend to like the second one better. Essentially, if you notice what we did in that problem, is that we took the first term and the last term and added them together, and then took that answer, multiplied it by half of how many things we were adding up. That's what this formula is saying. I like to write it a little differently. I like n over 2 times a1 plus an. And that is the sum of the first n terms of an arithmetic sequence. Now, what the book is doing for this first formula is essentially saying, well, hey, we know what a sub n is. We have a formula for it. It's this. And so they're plugging that into there, and it simplifies out to this. Sure, you could memorize that formula. I think it's an extra formula that you don't need to memorize. So, number 3. What is 100 plus 94 plus 88 plus 82 all the way down to 10? Well, it's asking for a sum, so I'm going to use my sum formula. I need n over 2 times a1 plus an. I don't know much here. I don't know how many terms this is. I know the first term is 100, and the last term, the nth term, is 10, but I don't know n. So I have to figure out n. Well, I can do that using my a sub n formula. I know my first term is 100 plus n minus 1 times d. Common difference I can tell is negative 6. And instead of a sub n there, I'm going to actually plug in the term I want to find what term value it is, 10. So I'm going to erase that to make this look a little bit better. So I can use, if I know the term is 10, I use this formula to solve for n. So that's negative 90 equals negative 6n minus, or plus 6, and negative 96 equals negative 6n. So n equals 16. So that means 10 is the 16th term. So now I can actually solve that it's s sub 16 equals 16 over 2, 100 plus 10, which is 8 times 110, which is 880. Number 4, we've got good old summation notation now. The key to these problems is recognizing arithmetic. If you recognize that the pattern that we're supposed to sum up is arithmetic, we can then use our formula. So you almost like do a little check. Arithmetic? Yes. Okay. So I need to just know a few things. I need to know how many terms. I need to know the first term. And I need to know the last term. Okay, we talked about this in the first video. From 4 up to 50, how many terms is that? It's one more than the subtraction. So if I do 50 minus 4, that would be 46. So this means I have 47 terms. My first term is what I get when I plug in 4. So I do 16 plus 3, so that's 19. And my last term would be plugging in 50. So that would be 200 plus 3, which is 203. So now I can do s sub 47 equals n over 2 times 19 plus 203, first term plus last term, and we get 47 over 2 times 222. That's 47 times 111, which is 5,217. For part B here, very similar. We have to notice it is arithmetic, and so then let's think through what are the things I need. I need my first term, I need my nth term, and I need n. First term, plug in 1. I'm going to get 12 minus 5 is 7. Nth term, plug in n. So I get 12 minus 5n. And then n is how many? Well, it's n, because I'm going from 1 to n. So I am going to have my sum of the first n terms be n over 2 times the first term plus the last term. And I can simplify that. That's n over 2 times 19 minus 5n. And that would be it. We could distribute that out if we wanted, but this works too. All right, one last word problem. Based on the pattern shown, how many rows would it take to get exactly 624 Patricks? So I kind of want you to try this here. I'm going to give you a little hint. We've got n equals 1, n equals 2, n equals 3. That's the number of rows. And you can figure out how many Patricks are in each row, A1, A2, A3. So you should be able to find a common difference. And we know that the sum is 624. I'm supposed to find out how many rows. N equals question mark would get us there. Pause it, try it out, see what you get. So you end up with a quadratic because we don't know n, and when we plug into our formula with a sub 1 plus a sub n, the first term and the last term, again, I don't know what the last term is. I don't know how many Patricks are in that last row. So I have to end up solving with an n involved in the problem. And you get this quadratic. You use your calculator or use a graph. You get n equals negative 26 or positive 24. Obviously, we can't be negative for the n value, so we get that there are 24 rows of Patricks. Would give us a total of 624. All right, that is all. Thanks for watching.